On the Regent, you might be given a question involving an exponential function, and you'll be asked to evaluate it at two different x values or two different exponent powers to see what the difference between them will be. For example, you'll be asked to find how much does the value of a certain object, let's say how much does the value of a computer decrease from 2 years after you bought it until 3 years after you bought it. Let's look at an example of this. This is question number 8 from the January 2015 Algebra 1 Regent. The value in dollars, v of x, of a certain car after x years is represented by the equation v of x equal to 25,000 times 0.86 to the x. To the nearest dollar, how much more is the car worth after 2 years than after 3 years? So we know that this is an exponential function because we have an x, we have a variable in the exponent. And we want to know how much more is this car worth after 2 years than after 3 years. So we have to see how much is it worth after 2 years and how much is it worth after 3 years and what is the difference between them. So let's evaluate v of 2. v of 2 is equal to 25,000 times 0.86 squared. And what is this? Let's do it on the calculator. 25,000 times 0.86 squared. And it's worth 18,490. And now let's evaluate v of 3. How much is this car value? How much is the value of the car after 3 years? So we have 25,000 times 0.86 cubed, and that is 15,901.4. And let's find the difference between these. How much more was it worth at v of 2? So we want to find what is v of 2 minus v of 3. And we have our values for v of 2 and v of 3, so we want to do 18,490 minus 15,901.4. That is equal to, let's do it on the calculator. Instead of retyping the numbers, we could scroll up until we are highlighted over 18,490 and press enter to copy it to the next blank line. We could type a minus sign and we could highlight 15,901.4 and press enter to copy it down to next to there and press enter. So now we just subtracted them, and the difference between them is 2,588.6. And we want this rounded to the nearest dollar. So this becomes 2,589, which is choice 1.